So in this video, we're going to talk about systems of linear equations that have three equations. And I think it's easiest if we just jump right into an example just to kind of show you what I'm talking about. So notice what I've got here. This is a system, but now like normally when we see systems, it's like two equations, two variables. Here I have three equations and I have x, y, and z. So having the z, like the extra letter, adds another level of complexity to this. So it's going to take us a little while to get through all of this. Just a heads up, this video is a bit longer just because these problems take a long time to get through, but I'm going to show you kind of the breadth of different types of problems that you'll encounter. So I highly recommend that you take notes alongside this example. It'll just help you to retain it a little bit better because, like I said, this is a little bit more complicated, so I think you've really got to get your hands dirty with the material. Okay, so to begin, really the first thing that you want to do is kind of get organized, and I like to start by just kind of numbering my three equations. And what you want to do is you want to take a moment to look at all of your variables and just notice if you could maybe use elimination, say, very easily with any of the equations. So in this particular example, I notice I've got z here and minus c here. So this pair of equations kind of lends itself to elimination, and so you always want to kind of go with that path of least resistance. And after you decide kind of that you want to eliminate a letter from, say, these two equations, then you have to eliminate that letter from all equations. So let me write that out. So just to give you kind of a heads up of what we're going to do, so we're going to choose a variable to eliminate from all three equations, and to eliminate, you end up having to use one of the equations twice to make that eliminated variable happen. So I know that sounds like a lot, so let's now just take a look at how to actually do this. So like I said, I noticed that I could very easily eliminate the z's here. So where I'm going to start is by taking these two equations to kind of get the whole process started. So let me clear some space. And where I want to start now is I want to just write down those two equations one more time just to keep myself nice and organized. And okay, I've got everything written down. So now we're just going to eliminate. So, you know, I'm assuming at this point, if you're watching this video, you're familiar with that method. So I can just really add straight down. So this is going to give me x plus 2y. The z's have dropped out, and so this whole thing's going to equal 4. So, okay, so now I have gotten this equation down to two variables or two letters, and what I'm going to do is I'm going to now letter this. So I'm going to change my organizational system. Okay, now, once you choose that letter to eliminate, you have to also do it in the remaining equation. So this equation 1 still has this z here. So this is what I mean now, in that you have to use one of these equations twice to eliminate that variable. So it doesn't matter which equation that you want to use. I would like to use this equation because it's already got a negative z, but you know that you're going to have to manipulate this one. So I'm going to have to multiply this one by 3. So what I'm going to do here is now I'm going to kind of start thinking about the next part. So I'm going to take these two equations together. But also what I want to do is I want to multiply this by 3 so that I can have the 3z and the negative 3z drop out. Okay, so now let's see, can I actually let me move this over and give myself a little more space. Okay, so I've got this, let's see, I'll number them out. X plus 2y plus 3z equals negative 11. And then for the third equation, I'm going to go ahead and multiply everything by 3 as I go through this. So negative 2 times 3 is going to be negative 6x, and then 3 times 3, so this will become 9y, minus 3z equals 12. So I multiply each part by 3. Now I've got these all lined up, and now I can go ahead and do my elimination. So if I add these straight down, now I get x minus 6x is negative 5x, 2y plus 9y is 11y, my z's are going to drop out, and then negative 11 plus 12 will be 1. And so now here is my second equation. So I'm going to label this b, It's a terrible looking B. Let's see, I'm going to label this B like that. Okay, so now what I want to do is I want to take these two new equations, A and B, and I just want to stack them next to each other so that you can kind of see where this is going. Okay, so now that I have eliminated my z's, here are the two equations that I'm left with. And if you just take a breath for a second and just look at this, this now looks like a system like what we used to solve all the time. And so this is kind of the point of this technique, is you eliminate that one variable and then you end up reducing this situation into just a system of two equations with two letters, which we feel far more comfortable with, or it's just a lot more straightforward to solve. So from here, now you're just going to solve this new system as usual, using any techniques that you want. So let me note that. So now what I want to do is I just want to solve the new system. And I didn't even put like any specific methods that you have to use. It's really whatever you think will be best. Personally, I think it will be easiest if I multiply this by 5. So that's what I want to do. So let me make some space. So this will become, 5x plus 10y equals 20. And then this other equation is negative 5x plus 11y equals 1. And so now if I use elimination again and I just add everything straight down, I get 21y equals 21. And if I divide both sides by 1, then I'm going to get that y, let's see, I'll note it up here, y equals 1. Okay, so now that I've got my first solution, now I can go ahead and finish solving this system. So I need to solve for x. So I'm going to plug this one into the first equation. So this is going to be x plus 2 times 1 equals 4. So that'll be x plus 2 equals 4. If I subtract off the 2, I'll get that x equals 2. All right, so I'm going to note that up here as well. So now I have y and I have x, and I still have to find z. So now that I have these and I look back at my original system, well, you can probably see now what we need to do. We need to just take these two solutions and plug them into any one of these equations. So now we go back to the original system. So basically, like, these have done their job. We don't need them anymore, so I'm going to clear a bunch of space. And so let me just note what we're doing now. So now using the solutions from that A-B system, we solve for the remaining variable in the original system. So let me clear some space and we're going to do that. Okay, so I'm going to use this equation here and plug in those values. So this will become 3 times 2 minus 1 plus z equals 0. So now I get 6 minus 1 plus z equals 0. So this becomes 5 plus z equals 0. So I can subtract off the 5 to get z equals negative 5. So let me note that up here. Okay, so now we are really in the home stretch. There's really just two things that we've got to do. So let me clear some space. And now let me write just what we have to finish. So the final thing that you want to do is state your solution as an ordered triple and then check it. So in this case, the ordered triple, so it's going to go x, y, z, so it goes in alphabetical order. So this is 2, 1, negative 5. And now basically I just want to take a moment to make sure that this works by plugging this into each equation. So let me clear some space. Okay, and so plugging into the first equation, this will be 2 plus 2 times 1 plus 3 times negative 5 equals negative 11. So let's see if that's true. So this will be 2 plus 2 minus 15 equals negative 11. And so that really comes out to 4. This will be 4 minus 15, so that does equal negative 11. So the first one is good. The second one, now I'm going to plug this in. This becomes 3 times 2 minus 1 plus negative 5 equals 0. So this will be 6 minus 1 minus 5. That definitely equals 0. Okay, clear a little space. And now for the last equation, so this will be -2 times 2 plus 3 times 1 minus -5. So is that going to equal 4? So let's see, this will be -4 plus 3 plus 5. So does that equal 4? Well, -4 plus 3 is -1, and -1 plus 5 definitely equals 4. So we can see that this ordered triple works in all three equations at the same time, so we know that we found the right solution. So as you can see, this does take just a little bit of time to kind of get through, and I highly recommend having kind of those steps in front of you as we go through the next problems, because I'm going to basically just be working from those going forward. So what I want to show you next now is actually what I think is like a slightly easier version of this type of problem. So take a look at this system. It's x minus 2y equals -3, x plus 6z equals 3, and then 2y minus 4z equals 6. Okay, so in this case, this is still three equations, and we still have three different variables, x, y, and z. But notice that I'm only using two of those variables in each equation. So whenever something like this happens, you really still follow the same process, but what we're going to find is that it's actually a little bit simpler to get through. So as I'm looking through my variables here, so the first thing I'm thinking about is what looks like it might be the simplest to eliminate. And so it looks like either doing this 2y, this -2y, and this 2y, or these x's. Okay, so I'm going to choose the one that maybe looks just slightly more complicated. And so let's see, I'm going to call this 1, 2, and 3. Okay, so I want to eliminate the y's. So I'm going to use this equation and this equation. So just kind of go with me here. Let's see what happens. So I've got x minus 2y equals -3. And then I've got, let's see, I'll write this as 2y minus 4z equals 6. So let me actually make a little space up here. So notice just how I decided to write out these equations. So I wanted to line up the variables and the equal signs. So this just makes it a little bit nicer to look at. So if I do my elimination now, so I am adding x to nothing. So this will just be x plus 0 is x. The y's drop out, and then I'm left with minus 4z equals 3. Okay, so this is why this is a little bit simpler than the last problem, because look at what we have now. We have this equation x minus 4z equals 3, and then look at the equation that we didn't use. So I used, oops, and I didn't label this other one. So I used equations 1 and 3 here. I have not used equation 2. But notice that equation 2 is only in terms of x and z, and that's exactly what we've made here. So if you are missing variables and then one of your eliminations will give you this equation in two variables and the other one has those two, only those two variables, then you can actually just kind of move forward with the whole process. So let me mark this as A. Let me clear some space. And now what I want to do is I want to line this up to equation 2, like this. So the whole point of this is really just to get two equations in two variables. And so if you don't have to go through as many steps to get to that, that's okay. So in this case, we are all ready to go, and I'm going to use elimination. So what I'm going to do is I'm going to multiply this by -1 so that the x's drop out. So now I've got -x plus 4z equals -3, and then x plus 6z equals 3. So now if I just add straight down, I'm left with 10z equals 0. And if I divide both sides by 10, I'm going to get that z just equals 0. Okay, so now I can go ahead and solve for the x in one of these equations. So let's see, I will plug this 0 into this, how about this A equation? So this is going to be x minus 4 times 0 equals 3. So this really just comes out to x equals 3. So I have x equals 3. And so now I do the same thing as I would have before. So I have to plug one of these values into one of these equations, but it has to be one that has y in it. So notice, like, if I use this first equation, I only have an x, I don't have a z, and that's okay. So I can just plug in the x equals 3. So let me make some room. All right, so taking equation 1, I'm going to plug in x equals 3, and then I've got this minus 2y equals negative 3. So this is really just 3 minus 2y equals negative 3, and then I can subtract off the 3's to get negative 2y equals negative 6. Divide both sides by negative 2 to get y equals 3. So there we go. Now remember, I said that we do want to state this as an ordered triple, so this will be 3, 3, 0. And then I highly recommend with these types of problems that you do check them, because it can be pretty easy to make like a little mistake. So let me clear some space. Okay, so let's start with the first one. So this will be 3 minus 2 times 3. So will that equal negative 3? So that's 3 minus 6. So that definitely equals negative 3. So equation 1 checks out. So now moving on to the next one. So this is going to be 3 plus 6 times 0. So we can tell just by looking at that that number 2 is going to check out. And then for the last one, this is 2 times 3 minus 4 times 0, and that does indeed equal 6. So we are all good to go with this one. All right, so going forward, I'm going to show you just like 2 other basic problem types, and then that'll be it for this video because this is already pretty long. But just FYI, if you want to see more of any of these types of problems, I have another example video, and then you can watch basically like another example of each type of problem that I'm showing you here. So for types of problems like this, like the full, you know, the whole thing, and then I have, you know, another one with like just the 2 variables in each equation. And so let's jump to these other examples just so you can kind of see a couple other things that can happen. And then that'll be it for this video. But like I said, if you want to see some more, I do have more videos. Okay, so for this example, I really want to encourage you to actually try this particular one on your own. So let's go ahead and label this 1, 2, and 3. And I'll just go ahead and tell you something weird is going to happen here. So just to keep it consistent, why don't we start by using equations 1 and 2? And notice that in this particular example, we're not in a situation where it would be really simple to cancel something out right away. So we're going to have to manipulate one of these equations no matter what. So just to keep it simple, why don't we work on eliminating the z's from 1 and 2, and then you can also do it from 2 and 3 if you want. So go ahead and try that, and then hit play when you're ready. Okay, so to do this, I need to multiply this equation by 4. So I'm going to have the first equation, which I'm not manipulating. And then I'm going to have the second equation. So I'm multiplying everything by 4. So this will be negative 8x minus 20y plus 4z equals negative 16. So as I add everything down, so notice the x's drop out. 20y minus 20y means the y's drop out. And then also the z's drop out. So this side is going to be 0. And then 16 minus 16 is also 0. So this is something that can happen when you're working through some of these types of situations. And the interpretation is just like it would have been with a system of 2 equations. 0 equals 0 is a true statement. All of the variables dropped out. So we interpret this to be infinite solutions. And so we can use this notation. Okay. So now let's take a look at one more example. Okay, so for this one, let's do the same thing. So I'm going to label these 1, 2, and 3. And once again, I want to encourage you to kind of work alongside of me and pause the video here. So for this one, as I'm kind of looking through everything, once again, we don't have a place where we're going to have a nice, easy elimination. So why don't you work on eliminating the x's in this case? So you can use 1 and 2 and 1 and 3 to eliminate everything. So maybe pause here, give that a try, and then hit play when you're ready. So I'm going to start by taking equations 1 and 2, and I'm going to multiply this one by negative 2. So I'm going to take this equation and this equation. So this is going to be negative, let's say this will be equation 1 that I'm using and manipulating. So this becomes negative 2x minus 8y plus 6z equals negative 4. And then for this other one, this is 2x minus 3y plus 2z equals negative 5. Okay, so now I can start with the elimination. So as I work through this, the x's drop out. I'm left with negative 11y plus 8z equals negative 11. Okay, cool. So this is going to be my equation A. I'm going to make some space. And now what I'm going to do is I'm going to use equations 1 and 3. So I'll go ahead and just kind of mark this. Let's see, I'll even leave my note here. Except now instead of multiplying by negative 2, I'm going to multiply by negative 3. So let's see, I'll replace this with negative 3, and I'm going to use this equation and this equation. So equation 1 will now turn into negative 3x minus 12y plus 9z equals negative 6, and then equation 3 is 3x plus 12y minus 9z equals 2. And so now you'll notice as you add down, so the x's drop out, the y's drop out, and the z's drop out. So once again, I'm left with a 0 here, but then I've got negative 6 and 2, so this equals negative 4. So this is something I just want to point out, that sometimes as you're going through this, you might get one equation that actually worked out, but the other one could have something like this, either 0 equals 0 or 0 equals negative 4. So either way, once you get this result, it's still that same conclusion of this would mean no solution. 0 does not equal 4. So that's what tells you that this is no solution. So I can just use the empty set. So whenever that pops up, you're just allowed to go ahead and automatically conclude that, and you don't have to go any farther with the problem. Okay, so that really covers all of the basic problem types. So like I said, if you want to see more, I do have another video of examples of all of these different types. Any questions, you can always leave me a comment. Thanks for watching, guys. I'll catch you next time.